Hi guys, welcome back to Infinite Math Help Squared. This is the first video in a 4-part series all about the Pythagorean Theorem. This first part is going to be deciding, is this a right triangle that we're looking at if we're given 3 side lengths? So the first thing that I want to ask you is, did you know that when you look at the Pythagorean Theorem, you get a lot more information than just right triangles? If you have the 3 side lengths, and you can simplify it down, then you'd actually know if you're looking at a right triangle, obtuse, or acute. So the key here is to focus on this part right here. When you've simplified it, is it going to be that the c squared is less than the sum of a squared and b squared? If then, it'll be acute. If it's equal to, it'll be a right triangle, and if it's actually greater than, then you're looking at something obtuse. So if you think about it, here's your right triangle, and if you take that side length and stretch it to the right, then you've extended the angle and it becomes greater than 90. But if you actually take it and shrink it, then you get something that's acute, which is less than 90. Mind blown, right? Okay, so let's actually try testing some side lengths. This is actually a pretty popular one, and I'll explain that in a minute. But let's pretend they say that the side lengths are 3, 4, and 5, and we want to know if it's a right triangle. Let's take the Pythagorean theorem and plug in the information they gave us. Okay. So we have c squared equals a squared plus b squared. Now remember, the two smallest ones are going to be the legs, and your a and your b are your legs. So we have 3 squared plus 4 squared. And according to Pythagorean theorem, if it's a right triangle, which that's what they're asking us for here, then it has to be equal to 5 squared. 5 is the longest side out of the 3, and we call that the hypotenuse. So we have leg, leg, and hypotenuse. Well, okay, now, so let's simplify. 5 times 5 is 25. 3 times 3 is 9. And then 4 times 4 is 16. So the question here is if you add these two, do you get 25? And the answer is yes, you do. So since there's equality here, then remember, according to this first chart here, we have equality, which means we're looking at a right triangle. Now, the reason why I chose this one is because this is also called a Pythagorean triple. Once you've proven it, right, we call that a Pythagorean triple. Once you've proven it, it's not going to change. Right? The only way that it would change is if they switch up what it is on the actual triangle. So this is supposed to be a right triangle. And if this is a leg and this is a leg, because they are the two smallest, then here's your hypotenuse, and it goes 3, 4, 5 like that. Now, if they ever showed you something else and they tried to say, so like what you can do to test it, right? Your two smallest ones, the 3 and the 4 together make 7. 7 is greater than 5, so then this triangle is possible. It's possible, and we just proved that it is a right triangle. Let's see. Let's try another one. Let's test this one, 6, 8, and 12, and let's see what we get. So c squared equals a squared plus b squared, and our two smallest are 6 and 8. So 6 squared plus 8 squared, and it's supposed to be equal to 12 squared if it's a right triangle. So we have 144, 36, and 64. Okay, so the question here is when you add these two together, do you get 144? And the answer is no, right? you have 144, and on the right side is 100. In this case, 144 is greater than 100, and if you go back to your chart here, greater than 100 would mean that it's obtuse. So this is not right. The Pythagorean triple that goes with this would be 6, 8, 10. All right, so that's all I have for you today. And until next time, and you'll get part 2.